Okay guys, so far we have learned how to graph, but today we're going to talk a little bit about how to interpret these graphs. So we're not going to deal with specific numbers with them, we're just going to look at patterns of how things are graphed. Okay? We're going to start with a position versus time graph, and we're going to start with just a basic line. Okay? So the first thing we always want to remember to do is to label our axes, and we want to remember that it is what versus what when we're titling it. That's right, y versus x. Good. So our position is going to be our y-axis, and our time is going to be our x-axis. Very important to title, okay? Now we're going to draw just a sample line that we would get on this graph. So say we have just a straight line going up this way. All right, we've calculated the slope. If we remember in our graphical analysis, we get a little box here and it tells us some different stats. Well, we want to learn what these things actually mean. One of them is the slope, and it gives us some information, so it'll give us a number, and then it'll usually have some form of units here. Okay? So these units are very important. They tell us what the slope represents, basically. And if we think about the slope of a line, we remember that it's rise, which is our y direction, over run, which is our x direction. So essentially it's y divided by x. All right? And when we think about what those things represent, it's the same thing as position divided by time. Okay? So one way that we can think about that is it's similar to distance over time, and we know that from our equation v equals d over t, that represents our speed, basically. Okay? So, all this mess aside, we want to remember that slope for a position versus time graph equals speed. Okay, moving forward. Our next one, we have a speed versus time graph. Okay? So if we have our speed, we're going to list it on the y-axis. So we're going to call it speed, and we're going to put our units there. We're just going to use meters per second as an example. Okay? On our x-axis, we're going to put time. We're going to say that's in seconds. Okay? So now, again, if we draw our slope, we're just going to draw a run-of-the-mill one. We're going rise over run again. So this time our rise is our speed, and our run is our time. So we know this time that we have speed, which is meters per second, divided by our time, which is seconds. Okay? So whenever we have a fraction on top of another, as basically as our divisor, then we take it and we move the bottom number to the bottom of the overall fraction. I'm drawing a blank on what the dividend and the divisor. Okay? So we're going to move that s to the bottom. So that's going to give us meters per second times second, which equals meters per second squared. Okay? That stuff should be mostly review. Another way that you can think of it is meters per second times 1 over seconds. if that helps you see how those numbers go on top and on bottom better. Okay, but basically what that gives us is a form of meters per second squared. Okay, and that is a form of acceleration. Okay, so our slope when we're dealing with a speed versus time graph is going to be acceleration this time. So again, we go back. Position versus time, the slope tells us the speed. Speed versus time, the slope tells us the acceleration. Okay? So let's work a couple of examples where we're drawing some different forms of this speed and acceleration. Okay. So in this graph, we can see here, Mr. Vernon and Chad race across the football field and back. Chad takes an early lead running at a constant speed and stops momentarily at the turnaround. He's played right into Mr. Vernon's trap. As Mr. Vernon gets to the turnaround, they both sprint back, but this time they go as fast as they can. And they're running at a constant speed once again. This time, Mr. Vernon runs as fast as he can and beats him. Okay? And then as we can see, the UGA fan finishes last, as always. Except for the past few years, but those don't count. So, what would the graph for Chad and for Mr. Vernon look like on a position versus time graph? Okay, so let's do Chad's graph first. We're going to do Chad's in red. Okay? So we're going to mark that. Chad is going to be red. Okay. So he starts off at a pretty fast constant speed. Oops. First we want to label our graph. Almost forgot that. So we're going to say position versus time. Okay, so they both start at the beginning, which we're going to count as right here. Okay? So Chad goes pretty quickly. So he's covering a large position, a large amount of position in a small amount of time. So his slope is going to be steep. So he goes pretty fast at the beginning, and then he gets to the turnaround point, and he decides he's going to rest for a little bit because he's got this in the bag. Okay? Then he turns around and he sprints back to the other side. And this time he goes as quickly as he can, but it's about the same speed as he went before. Okay? Let's actually spread that one out a little bit. I'm going to redo that. So he goes at a decent speed, then he slows down and stops and waits. Then he goes back a little bit more quickly. Okay? So he's got a slope here that's pretty fast, or that's pretty steep, so that's showing that he's moving pretty fast. Then he stops, so we see that his position doesn't change over this whole amount of time. So he's standing still. Then his position goes backwards. So he's returning to the start here. He runs across the field, then he stops, then he runs back down. Okay? So that's how his would look. So Mr. Vernon, on the other hand, he starts off slower than Chad. So Chad thinks he's got this thing won. And then he gets to the turnaround point, and that's where they both turn back as fast as they can. So they both start from the other side, and this time Mr. Vernon goes as fast as he can, and he makes it back in a shorter amount of time. So for Mr. Vernon's graph, we see a slower slope at the beginning until he gets to the halfway point, showing that he's going slower than Chad was at first, but then it's a steeper negative slope, so he's returning back to the start at a quicker pace. Okay? So if we clarify what each of these things represent, all right, we're going to mark a couple of marks on here. So for Chad, we're going to put an A, a B, and a C. At A, he is traveling at constant speed forward. So, constant speed forward. At B, he's resting. And C, it's fast return. That represents his position. For Mr. Vernon's, it's just an A and a B. It's A is slower forward than fast return. Okay, so let's take a look now at what the other graph would look like. So now we're doing speed versus time. It's the same question. They're doing the same race, okay? So again, we're going to do Chad in red. Okay, so when he starts out, this time we're talking about speed. So it's a little bit different. It's kind of hard to wrap your head around the difference at first, but then once you do, things start to make sense. Okay, so for Chad, he starts out at a pretty decent pace. Okay, he runs, then he gets halfway across, and he sits there. So his speed at this point would be 0. So it's going to drop all the way down because he's not moving. Okay, so he runs across and he just stops right there. All right, that's why we have a straight drop right here. So he sits there for a little while waiting for Mr. Vernon. Then when Mr. Vernon gets back, he goes really quickly back to the end. So he runs for a short amount of time at a really fast pace. Okay, so those are supposed to be straight up and down. So we've got A, B, and C. All right, this time, since we're talking about speed instead of position here, this is like showing that he's running at, say, 3 meters per second here. Then he's running at 0 meters per second because he stopped. Then maybe he's running at 5 meters per second on the way back. The reason there's no negative here is because we're just talking about his speed, and speed doesn't have direction. Okay? So, if we write Chad on here, A is medium speed, we'll just say. B is stopped. And C is fast speed. Okay? Now for Mr. Vernon's, we're going to say at the beginning, he goes a lot slower for a while. Okay? But he doesn't stop, so his speed stays the same. That's supposed to be straight there. Okay? And then once he catches Chad at the other side, his speed goes even faster to return home. And he gets home, or back to the other side, a little bit sooner. Okay, so if we mark our A and our B here for Mr. Vernon, he goes slow speed to start, but then he runs basically at the speed of light on the return, and thus defeats Chad. Okay, so let's do a couple of other scenarios that we can see on position and on speed graphs. Okay, so we're going to do a position graph now, and I'm going to cheat and use the automatic lines because I need these ones to be a little bit straighter. Okay, so we're going to do a sample now, and you can find these notes of a similar graph on the blog or on the Google Drive. We're just going to draw one that goes up for a little while at constant speed, then rests, then returns, then goes back up, and then back down. Alright, so we're going to describe what these positions are. Oops. Okay, so we're going to label them again. We're going to say position A, position B, position C, position D, position E. Okay, and it's very important that we do a title here because otherwise we won't know what kind of graph it is. So position versus time on this one. Okay, and we're just going to list what each of these things mean. Okay, at point A, the object is moving at a constant speed in motion. Constant speed. Okay, at point B, the object, so we can see at point A its position is increasing. It gets up to right here, and then during point B the position stays the same, so the object is stopped. Okay, at C the object is moving and it's returning to the start. Okay? Alright, and then finally at points D and E, as you guys have probably figured out, it's just a faster speed out and faster return. Okay? So those are some different scenarios to go over. Okay, and if we talk about a slope, one other thing to note here, if we look at the slope where it is negative, we know that position over time is going to give us speed, but in this case it's actually going to be negative. So whenever we have a speed with a direction, that's what we call velocity. So actually what we're going to do, because unfortunately this thing won't let me record and I'm not starting over from the beginning, we need to change this one to distance here. Because it's actually distance over time that gives us speed. So we're just going to make a quick amendment to that. Oh, that's the wrong one. Oh dear. Because in that case we couldn't have a negative slope. Okay, so we're going to return back up to here. Here we go. This is the one we wanted to change. Distance. Okay. So this is going to give us our slope equals velocity. Okay? So, our next one is going to be a speed versus time chart. Okay? So we're going to do the same kind of thing, just kind of talk about a couple of ways that you can see things on here. Okay, so as we draw these out, we're going to label them A, B, C, D, E, F. Okay, so we're going to go through this one a little bit quicker. Okay, so on this one we're talking about speed. Okay, so A means that speed versus time. Speed and time. So A means that the object is increasing in speed, therefore it has a positive acceleration. So it is accelerating or speeding up it's speeding up until it gets to the part where B is, in which case the speed is still increasing but not by as much. So it's accelerating more slowly. So that would be like similar to when you're sprinting and you start to get a little tired. So you're not accelerating as quickly. Okay? So then at the top here, it's not, we tend to think that this is where we're stopped, okay? But we're dealing with speed here. So we're still going at a high speed here. We're just not speeding up or slowing down, okay? So in this case, we're going at a constant speed. Okay? Then at point D, we are slowing down. At point E, okay, so at point D, it's a rapid deceleration. It goes down quickly. But at point E, there's less change in speed. So it's, in essence, slowing down more slowly. So we're going to just say less change in speed. Or less deceleration, we'll say. Okay, and then finally F is, it goes back to a steep slowing down, so it's more deceleration. Okay, so we'll talk about this a little bit more, and you guys will have the opportunity to ask questions when I get back tomorrow. But those are kind of the basics of reading a graph.